Hello, I'm Adriano Mancini from Università Politecnica delle Marche, and today I will present an approach for people counting on low-cost embedded hardware during the SARS-CoV-2 pandemic. The main focus is on the detection and tracking of people in a crowded environment, especially in location as retail, airport or station for security purposes. During this period, we know that it's really critical the management of people that should enter inside the building, because we have strong requirements on the maximum number of people that should be at the same time inside a building. So for this reason, it is necessary to provide advanced solution that could detect in real time the number of people that are in a retail environment, for example. So what we want to do is to develop a system to control the people that are entering inside the building, and this is a tool that should be used by a manager of the retail environment. The previous work that we have done on this topic rely on RGBD. So with depth, we use the depth information in order to segment, as you can see, starting from the RGB plus depth, we segment the people as also in a crowded condition. So this is quite nice because this works in real time, and also the number of people actually does not represent a critical issue. But the main problem behind this is the use of a RGBD camera that is not so cheap as a standard RGB camera. So RGBD is a nice tool. We also released a dataset that allows you to evaluate your algorithm on the dataset that we acquired and annotated for you. You can find the dataset on the website at the end of the slide. So what we have done is to design of a new network that is able to count people in a crowded environment. More details are reported in the paper that is available online, and the references are at the bottom of this slide. What we have done is to optimize as much as possible the use of this data, and we obtain good results in terms of performance. The network that we proposed that relies on RGBD data, in any case, is able to ensure an accuracy that is over than 99.46%. So it's really a good performance with a really high values in precision and recall and F1 score. Of course, the RGBD is really nice, so we have a lot of experience on that. We suggest to visit our website also for a dataset available for this purpose. But in this work, what we want to do is to focus on people counting that are crossing a line of interest starting from RGBD stream that is captured by a camera that is placed in a top view perspective. Why top view perspective? Top view is needed in order to ensure the privacy. So it's privacy preserving approach. Instead, using a frontal camera, the top view allows you to preserve the privacy of the users. So this is a nice feature that should be of interest for the manager of retail environments, for example, in order to minimize the impact on the privacy of the end users. The developed solution is designed for real-time environments, so there is no offline processing. The processing is online. So it is done on a low cost and hardware. This is a mandatory feature that we considered during the design of the system. And the other requirement that is also a challenge, of course, is that the count of the people should be performed not just for one user, but for multiple users. So the approach should be able to work also with contemporary and with multiple simultaneous shoppers. We acquired a data set during the pandemic situation in the market region, and some details following the next slides. Material methods. So the proposed framework is organized into 5 main stages. Image acquisition, transfer learning, people detection, tracking, and counting. For the image acquisition and transfer learning, this is a critical phase, of course, because the performance of the real-time algorithm is affected, of course, on the quality of data that we acquired. This is an aspect that we need to reinforce for future works, because we are also collecting right now more images, because it is really important to capture as much as possible the variability that is available inside our retail environment. The detection, tracking, and counting stages are really relevant for our purpose, and we used the criteria to count to detect if user is entering or exiting in a store. So between two successive instances, a segment is considered between the centroid of the respective detection. If that segment intersects the virtual line, then a crossing has occurred. Otherwise, the crossing has not yet occurred. So we consider this simple approach because this kind of approach should give an estimation of the number of people that are inside a building. Of course, considering the gate, we can have a positive count or negative count considering the direction. Positive means that the user is entering, negative counting is we are subtracting the number from the overall number of people inside the store. For the detection, what we have done is to use a mobile net v3 as basic architecture for the single shot multi-box detector. This is an approach that is light enough to be run on a low-cost hardware, because of course this is a mandatory aspect of our work. For the tracking phase, what we have used is to use the minimum output sum of the squared error. More details are in the reference at the bottom of the slide, and this is necessary in order to reduce the computational time, because we want to process each frame using the trackers, but we also use the detection network and SSD approach in order to identify the bounding box that we want to track. We use classical evaluation metrics as average precision, average recall, mean average precision. And for the dataset, as we mentioned at the beginning of this presentation, we collected 8,000 of images in real retail installation using a top view configuration. The annotation of the images was carried out in 3 different stages: before the virtual red line, below the virtual red line, and after the red line. The hardware setup relies on low-cost hardware that is based mainly on Raspberry Pi 4 and Pi camera module V2. As we mentioned before, we will run the neural network not every frame, but every n frame, in order to reduce the computational time and increase the output rate. This is really important because on this kind of low-cost hardware, the inference time is approximately 0.10 seconds. So is maybe could be critical in case the user is entering at high speed. So for this reason, we use the tracker in order to save time but the detection network helps the tracker in order to properly track the people that is entering or exiting into from a store. For the mobile net v3, we used the following configuration. And finally, what we got is a good results that, of course, should be improved by extending the dataset. This is, of course, something of preliminary because, as we mentioned, we need to work on that. We need to improve the performance. And the lesson that we learned that this kind of approach could be applied to every kind of store because the infrastructure is really easy to set up. Of course, the top view configuration preserves the privacy of the user. That was really important. And what we want to do for the next future in the next future is to improve the performance of the network by increasing the number of images and the number of conditions inside the store in terms of location and environmental condition, for example, the light and so on. We want to also evaluate other kind of networks for the detection task. And of course, what we want to do is to evaluate the system in other real environments as maybe public building, as university and so on. Thank you for your attention, and if you want, you can also look on our website to have further details regarding our neural networks and the available dataset that could be used by you. Thank you.